So today we will discuss on the refrigeration testing. So this testing is basically works on the vapor compression refrigeration system. So vapor compression refrigeration system consists of compressor, condenser, expansion device and the evaporator. So here you can see this is the compressor. Second component is nothing but the condenser. Third component is the expansion device, and fourth one is the evaporator. So in the circuit diagram you can see this one is nothing but the compressor. So low pressure and low temperature refrigerant is enters into the compressor, then it becomes high pressure and high temperature compressor, high temperature refrigerant. After that it enters into the condenser, that is air cooled condenser. Then it is converted the vapor into a liquid, and the phase change phenomena takes place at the constant pressure and temperature. Okay, so temperature and pressure is made constant, but phase is going to be changed in this condition. So still in this condition the temperature and pressure of the refrigerant is high. After that it is allowed to pass through the dryer, where it removes the whatever the moisture contents or the dust particle which are present in the refrigerant, so that get removed. After that it is enters into the expansion device. So it will get evaporated slightly over here, then pressure and temperature is reduced over here, and then the velocity of the refrigerant is increased, and that's why it gets evaporated. So whatever be the refrigerant which is coming from the bigger diameter of the pipe, it enters into the small diameter of the pipe, and that's why it get evaporated. After that it is enters into the evaporation or the calorimeter tank, where it gets evaporated, and it releases the latent heat to the atmosphere, to the water, and that's why water is get cooled. Again it comes back from the circuit, and again it enters into the compressor. So this is how the circuit is completed. So you can see here, this is the hermetically sealed compressor, where the temperature and pressure of the refrigerant is increases from the low pressure and low temperature refrigerant. Then it becomes the vapor. After that it is enters into the condenser. It is air cooled force convection air cooled condenser. So whenever it is passing through this tube, so in that direction the refrigerant is get converted into a liquid. Okay, so phase change phenomena takes place, and after that it is enters into the dryer. Okay, so here again the temperature and pressure of the refrigerant is high, and again finally it is enters into the expansion device. So you can see here the diameter of this capillary tube is very small, and that's why the velocity is increased, and that's why it get evaporated. After that it is enters into the calorimeter. This is the calorimeter. So you can see here there are several tubes through which the refrigerant is flowing, and the water is surrounding to it, right? So it releases its latent heat to the water. So obviously the water will get cooled, right? So how much amount of the water is getting cooled, or how much is the temperature maintained after the cooling, so that is nothing but the refrigerating effect produced, and the how much work or how much energy is consumed by the compressor to make it cool. So that we are going to calculate, and that is how we are finding out the COP of the system. So in this one the pump is there to stir the water, and heater is provided to maintain the temperature of the water. Whenever we are going to cool the water, then simultaneously we are heating the water and we are measuring the temperature of the water, so that the energy consumed by the heater is also be calculated. So you can see here in the observation table. Alright, so first one is the refrigerant temperature. T1 indicates the temperature after the evaporation. T2 indicates temperature after the compression. T3 after condensation, and T4 is after expansion. Then T5 indicates the water temperature. So this T5 here, T5 will be there. So T5 is nothing but the water temperature, and the energy meter for the compressor, that is how much time is required to for the 10 impulse, that we are going to calculate for the compressor and for the heater also. Then refrigerant pressure for suction as well as discharge, and refrigerant flow rate. So we can see here T1 is temperature after the evaporator, then T2 temperature after the compressor, T3 temperature after condensation, and T4 is the temperature after expansion. So this is now indicating us the value of temperature 1, T1, right? T1 after evaporator, then T2, okay, then T3 39.9, T4 that is minus 4.1. okay, so now you can see here we have calculated the value of T1, T2, T3 and T4, and T5 will be calculated from here, or T5 can be taken from this reading. Okay, so that is the T5. okay, that is over. Now second one is energy bidder or compressor. okay, so here we can find out the how much time is required for the 10 impulse of the energy consumption. So similarly for the how much energy is consumed for the heater, that we are going to find out again. So for the energy meter 1, start. okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, stop. okay, so here 43.41 second is the time is taken for the energy meter. Also for the heater we can calculate the time. Stopwatch. okay, just a minute. Start. okay, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. okay, so 20.19 I think so. 20.19 is the time duration which is required for the heater. Now another one is the suction pressure and discharge pressure. So you can see here from this one is suction pressure, right? So kg per centimeter square. So this is 5, 4, 3, 2, 1. So this is 1.25 around. okay, 1.25 kg per centimeter square. Similarly for the discharge pressure you can see here in kg per centimeter square, black scale, 10, and this is 9, this is 8, right? So this is 8.5 or 8.6, right? So that will be the value of discharge pressure. okay, then flow rate. Last one is the flow rate in LPH. So you can find out from the this rotameter. So the value will be around 1, 1.6, 1.8. okay, so around 1.8 is there, or 1.8 LPH. yeah. So this is how we can calculate, we can find out the different values which is required to find out the value of CO2 of the system. So later on we will do the calculation part in the different classroom, it's another classroom. okay, so I will explain you calculation part in the PPT of PowerPoint presentation. okay, that's it.